Good morning, everyone at home. Hopefully you are doing okay. We're going to start today. First of all, if you haven't completed the test from last Friday, don't worry. I'm going to give you a few minutes at the start of class on Thursday to kind of finish that up. There were quite a few students that didn't finish over both cohorts and stuff, so I want to give people the chance to do that. If you are under quarantine, send me an email. I will figure out a way to send back what you've done. I don't want to kind of put this off for 2 weeks because 2 weeks out now we're kind of getting into crunch time with April vacation to come back. So send me an email. I'll figure out a way to get back what you haven't completed on the test for you to finish up at home to send back to me. But to get into now, we're starting our triangles unit. Again, for those of you on quarantine, you're going to have to kind of follow along with this one on the videos and stuff over Ed Puzzle, so hopefully you can kind of pick up everything. Be sending me emails if you have any questions, just to make sure you kind of follow along and know what's going on, because there's a lot of stuff that we're going to cover in this. And then, like I said, the test for this unit's going to be the week before April vacation. So we're going to kind of not plow through it, but it's going to be a couple weeks before our next test, but we're going to cover a lot of stuff. So, triangles. Big thing we need to know about triangles, I think everybody already knows, is all the angles of a triangle have to add up to 180 degrees. It's actually called the triangle sum theorem. It's, like I told you before, theorems in math are stuff that we have originally proven. They're true. We've proven that they're true, so we can pretty much take it as fact that all the angles of a triangle have to add up to 180 degrees. I'm going to show you in, I think, the next slide why that is, but then we're also going to learn a little bit later on in the school year a formula to show us, again, why it's 180 degrees. So from that, I know that angle A, B, and C have to equal 180. So this is from a proof that we did in the honors geometry class. Again, I'm not going to show you proofs, have you do proofs. I'm actually going to show you the proof for this to prove out that they are 180 degrees, but I'm going to kind of do it out freehand without the proof, the formal proof, to kind of show you why it ends up being that all the angles add up to 180 degrees. So first thing we kind of look at, what they're telling us to do, whoops, sorry, I totally forgot the pen. To make sure the pen works as a pen. It's been a while since I've done this. Okay, so they're telling us to kind of draw in this line here through point A and then some imaginary point D that then makes it parallel to the bottom of the triangle BC. We just did a whole unit on parallel lines and transversals, and that's really what we've created here, is we've created two parallel lines. Like if I kind of extended B out and C out a little bit, we have two parallel lines cut by two transversals, AB and AC. So remember what we learned, that angle 4 here, sorry, I'm trying to figure out the best way to do this. So angle 4, I know, angle 4 plus this big angle here, which I'm going to call BAD, they're a linear pair. Remember we talked about that? They have non-shared side, form a line, so they're a linear pair. So when we add those together, they have to equal 180 degrees, right? We remember that? But I also know that angle BAD is actually angle 2 plus angle 5. So I can substitute this, angle 4 plus angle 2 plus angle 5 equals 180 degrees, right? That's what it's saying. Those three angles, when we add them together, we're going to get 180 degrees. Angle 2 is already part of my triangle. Whoops, I didn't want it dark blue, I wanted yellow. So angle 2 is part of the triangle. It's already inside, so I know it's part of the 180 degrees. What I also know when I kind of look at the transversals and stuff when we start thinking back to alternate interior angles and stuff, angle 1 and angle 4 are alternate interior angles, and then angles 5 and angle 3 are alternate interior angles, which we remember tells us that those angles are congruent. So angle 4 is congruent to angle 1, angle 5 is congruent to angle 3, which tells me that I can substitute for angle 4, angle 1. Now I have angle 1 plus angle 2. I can substitute angle 3 in for angle 5. They're going to equal 180 degrees. So that's a proof showing you why that is. We started with a linear pair. We broke it up into two other triangles. We've created other angles. We created the angles equal 180 degrees. So now I know that angle 1 plus angle 2 plus angle 3 all have to be 180 degrees. It started by us kind of filling in some information that we didn't have, but it's something we can do because that's the way geometry works. To show you what a proof looks like, to prove that out, I just kind of did it out by hand that way. It's a 10-step proof that kind of goes through a bunch of different things that we've kind of learned that we know about, but we haven't, we just know we haven't really learned and talked about. We've mentioned a lot of this stuff. So they told us to draw the AD, the first line. That's the parallel postulate. It's just parallel lines we can create. We had definition of a linear pair, which we learned last unit. If two angles form a linear pair where they're supplementary, we learned, which then creates the 180 degree thing, which is the definition of supplementary angles. Again, that's something we've already learned. We just haven't used in a formal proof. The formal proof goes through. We have to do all these steps. We have to say we have a triangle that was given. We had to draw in the parallel line. Did that. Reason why we were able to do that. A and B form a linear pair. Why are we able to say that? Because it's the definition of a linear pair. We have two angles that share adjacent angles, share a side, opposite side of the straight line. 4 and BAD are supplementary. Why is that? Because linear pair angles are supplementary. So then I can say the measurement of 4 plus the measurement of AD is 180. That's the definition of supplementary angles. Then we had the angle addition postulate, which we learned. Tells us that BAD is 2 plus 5. We plug 2 plus 5 into our original equation, which we did. That's a substitution thing. We kind of make the 4 is congruent to 1, 5 is congruent to 3. Again, that was the alternate interior angle theorem we learned last unit. Plug in the stuff there. That's the definition of congruent angles. If the angles are congruent, then their measurements are equal. And then we substitute 1 and 3 back in. So that is a big, long, formal proof that we don't have to do, that we are able to do for all the concepts that we are learning in geometry. I'm just not having you do them because they take a lot of time and they're really what everybody hates about geometry. So I just wanted to show what one looked like, big, long, ugly thing, to prove out a point that we're just going to go with, that angles of a triangle have to add up to 180 degrees. From there, too, we have at the vertex of each triangle, when we draw a triangle, at the vertex, there's an angle formed by one side, and then they're calling it an extension of the other side. So what they're doing is they're basically extending this line out. So if I do that here, I extend this line out. They're calling this angle here, this is the exterior angle they're talking about. And then we know for the exterior angles, what we have on the other side is what I'm going to call R1 and R2 is what they're calling the remote angles. They're the two opposite angles. Basically, they're the other two angles left over in the triangle from the linear pair that the adjacent angles form here. Does that make sense? So that's just the explanation of what the exterior angle is. It's an angle that's formed by an extension of a side and a side of a triangle. What I know now, if I kind of write these in as angle 1 and angle 2 here, if we kind of think through what we know about this, I know here that angle 1 plus angle 2 equals 180 degrees because it forms a linear pair, correct? Everybody sees that? That's a linear pair. What we're going for from here now is what they call this exterior angle theorem. There's a theorem about the exterior angle that tells us that that exterior angle equals the measurement of the two remote angles added together. And when we think about that, I know that angle 1 and angle 2 are supplementary because they're a linear pair. I know that angle 2 plus R1 plus R2 has to equal 180 degrees because it's a triangle. So that tells me that angle 1 has to equal R1 plus R2. Does that make sense? It's something we're going to be able to use to find missing measurements in triangles once we start looking at the way some diagrams are drawn. We're going to be able to find, oh, wait, that's an exterior angle. That has to equal those two. So then I can start filling in some information and get all the angle measurements for a triangle. Does that make sense? Okay, so here's an example to kind of show what we're looking at. Our first diagram, we want to find the measurement of angle 1. So I have angle 1. I know angle 1 is the sum of those two because 1 and this angle here are a linear pair. They're supplementary. They equal 180 degrees. I also know this angle plus the other two angles equal 180 degrees. So angle 1 is just basically going to be 80 plus 60 or 140 degrees. That's a simplified version. That's a simple example just to show you what we mean. What you're going to see in some of the stuff we're working on, though, is a diagram like the one on the bottom on the right here. It's on the right on your page. We're asked now to find the missing angles. So just so you know what we're looking at, we're looking for angle 2, angle 1, and angle 3. Does that make sense? That's what we're looking for. We have all the tools we need based on this exterior angle theorem to do what we need to do. We just got to kind of look at the pictures and kind of see, okay, where are we going? What's happening with everything that I need to know? So the first thing I look at, I can see that angle 3 is the exterior angle for angle 1, which is inside triangle VUT. So that tells me angle 3 equals, angle 3 is going to equal 36 plus 35, or angle 3 is 71 degrees. Does that make sense? Write that in. That's 71 degrees. That automatically tells me that angle 1 then has to be 109 degrees because it's supplementary to angle 3, or it's the third angle of the triangle that already has two angles that measure 71 degrees. So that tells me that angle 1 here now is 109. Everybody see that? Which then tells me angle 2 is angle 1 is this 80 degree angle plus angle 2. So angle 2 in that instance is going to be 29 degrees. Does that make sense? Everybody kind of see? We pieced together information about what we know. We knew linear pair. 1 and 3 are a linear pair. We knew what those had to equal. I also knew angle 3 had to equal based on the exterior angle theorem, the two alternate or opposite remote angles. Add those together. We're starting in angle 3. Sometimes you're not going to start from angle 1. We're going to have to kind of back into what do I know, what's the easiest piece of information to fill in, given our picture and the information we have, to get everything else. Does that make sense? Okay. Here's two for I want you to try. The first diagram has a lot going on. We're trying to find the measurements of 6 angles. Again, I will highlight them so you can see them. If you're they kind of alternate and bump around on different sides of the diagram. Just start with information you know. There's one specific relationship we see that it has to be something that I can go for. There are actually two possible places to start, but that unlocks everything else. And then the third one, number 12 there, just find out what the measurement for angle A is. Remember what we have going on there. See if you can piece that together. Enter your answers in the Ed puzzle, then come back and check and see how you did, like always. Okay, here are our answers. I kind of filled in some information in blue in the diagram that I pulled out from other parts of of what we filled in. But just so you know, I started my whole thing, my solution to this, I started with angle 4 because I knew those 3 angles there had to be 180 degrees. That's where I started. You may have started and saw angle 3 was actually a vertical angle here with the 65-degree angle, and that's where you could have started as well. That pieces everything else back together. Then you're looking at external angles, exterior angle measurements, and things like that. Because none of the angles are really related to each other. They're just kind of, they're all related to each other, though it works. But you wouldn't really be able to say, oh, angle 1 and angle 5 were the same measurement, things like that, which we did with the parallel lines and transversals. Again, this is some information we can use with that to make a really big angle problem if I want to on a test or a quiz. Just kind of you have to piece everything together because everything kind of builds on each other as we go through the rest of the school year. So we found angle 1 was 104. It's just basically the 68 and the 36-degree angle. It's the external angle of this triangle, so it has to be that plus that. Angle 2 we determined was 79 after finding out that 3 was 65. However, we did that. That left angle 2 as 79 because it had to equal the triangle had to equal 180 degrees. Sorry, I lost my train of thought. Angle 3, like I said, was 65. It's the vertical angle, that 65-degree angle. Angle 4, where I started, was 45 because 70 plus 65 plus angle 4 had to equal 180. So that was just 180 minus 135, which is 45. Got me to angle 5, which I found was 73 degrees. Because again, that's just, I know this had to be 62 degrees, or I have this exterior angle, which was 45 plus something. So 45 plus 73 is 118. And then angle 6, again, it's the exterior angle for this triangle, which is just 65 plus 82. That makes sense. Everybody got those, hopefully? Okay, next was finding the measurement of angle A. I see that I had a 60-degree exterior angle for that triangle, so I know that 60 degrees has to equal my other 2 angles. They told me angle A was x plus 36. These are vertical angles, so the other angle was x plus 46. So my equation was 60 equaled x plus 6 plus x plus 46, which made that 2x plus 82 equaled 60. So I found out that x equaled negative 11. Plug negative 11 into x plus 36, and I get the angle A was 25 degrees. Does that make sense? So now we know that would make the other angle 35, and off and running from there. Okay. Couple of triangle sum congruency corollaries that kind of tie into everything we did. They're related to right triangles, and they do make sense when we kind of think about what we're looking at with a right triangle. So they tell us the acute angles of a right triangle are complementary. Makes sense because one angle in the triangle is 90 degrees. The other 2 angles have to add up to 90 degrees because the triangle altogether adds up to 180. So that makes them complementary angles. So that's pretty straightforward. The 4.2 corollary is even more straightforward. There can only be one right or obtuse angle in a triangle. If the triangle's measurements can only add up to 180 degrees, we can't have 2 right angles in a triangle because then we don't have a triangle. That would just look like part of a box with an open top. Same thing for obtuse triangles. If we have an obtuse triangle with an obtuse angle, we can't have 2 of those. We can't have 2 angles bigger than 90 degrees because they're never going to close up the triangle. So that's a way to just kind of piece everything together quickly as you're going through triangle stuff. We don't really use them a lot. They are just things that we kind of know and have proven in the past, and are just kind of common sense when you start thinking about triangles. Okay, congruent triangles. Really congruent polygons as a whole, but mostly triangles what we're looking at. It's basically they can be mapped exactly onto one another, another geometric figure. Remember last unit we did the whole thing on transformations with rotations and reflections and translations. That's what they're talking about. When they're talking about mapped, they're talking about those three things. We had done an activity in Desmos, which we're moving like the L shapes onto the other L shapes with what the reflections are. That's what they're talking about. Can we move the one polygon figure directly on top of the other figure? They're congruent. Polygons can be congruent if and only if all the pairs of corresponding angles are congruent and all the pairs of corresponding sides are congruent. And this is where we kind of get into naming conventions of triangles. We have to kind of name them in the same order. Make sure we're naming things correctly. Best thing I like to say is when we look at a triangle, the names of a triangle we have in the figure here on our right. We have triangle ABC, we have triangle RST. So what that tells me, I'm going to kind of highlight some stuff in colors. Angle A corresponds to angle R. Angle B corresponds to angle S. And angle T corresponds to angle C. That's what we need to know. We need to know those are the corresponding angles. You'll make more sense when you start seeing different shaped angles. But now I know that the side AB here in our diagram has one congruent slash that's congruent, so their corresponding sides, they're congruent. Corresponding angles, A is congruent to R, corresponds to R, they're congruent, perfect. Angle B is congruent to angle S, has two arcs, perfect, they're corresponding, they're also congruent. T and C, they're corresponding, they're congruent. All three of my angles are congruent. That tells me the rule is if and only if. We will actually learn a little bit later on that if the three angles of a triangle are congruent, then the triangles are congruent because it makes the sides congruent. But they just continued on. AC corresponds with RT, congruent. BC corresponds to ST, congruent. Triangle, if and only if all the corresponding sides and all the corresponding angles are congruent. Here's an example. I'm not going to make you do any of these. We're just going to kind of give you, today we're just going to kind of give you everything. Asking is XYZ and RST. They want to name the pairs of congruent angles and sides. So when I kind of look at how this goes, I have angle X corresponds to angle R. Angle Y corresponds to angle S. And angle Z corresponds to angle T. So if I was able to kind of slide those over and place those one on top of the other, are they going to work? And they will, because I can reflect it. If I kind of reflect this triangle, flip it, then I can slide it over, everything would work okay. Does that make sense? But the corresponding angles and sides, they told us it was congruent too, so I know it had to work. But you had to kind of flip it to get it to look right. So angle X is congruent to angle R. That's one pair. Angle Y congruent to angle S. Angle Z, congruent to angle T. Make that a little neater here. Whoops. So those are the angle congruencies. My side congruencies then are XZ is congruent to RT. ZY is congruent to TF. And then XY is congruent to RF. Does that make sense? A lot of stuff we'll do. We'll be told what's congruent. You'll have the slash marks. You'll just have to kind of look and see, does it make sense that they're congruent? Okay. Third angle theorem. It's another theorem tied to triangles. Kind of self-explanatory, pretty common sense. If two angles of one triangle are congruent to two angles of the second triangle, then the third angles of each triangle are congruent. Think back to what we know. Angles of a triangle have to add up to 180 degrees. If two angles of one triangle are congruent to the two corresponding angles of another triangle so that they both have the same measurements, when we add those together in both triangles, it's going to leave the third angle being the same size. It's going to be congruent. It kind of makes sense. Properties of triangle congruence. This is stuff that's more open for proofs and stuff that we have to know, but just kind of look at it and say, does it make sense? Angle ABC is always congruent, or triangle ABC is always congruent to triangle ABC. Of course, that makes sense. 1 equals 1. Think of it that way. The symmetric property tells us that if ABC is congruent to EFG, then EFG is congruent to ABC. If A equals B, then B equals A. That's what they're talking about with the symmetric property of congruence. Transitive property, this kind of gets into the logic statement. If ABC is congruent to EFG and EFG is congruent to JKL, then ABC is congruent to JKL. Remember, I've talked about it before. If A equals B and B equals C, then A equals C. That's what they're talking about, transitive property congruence. So if I can prove one thing's congruent to something else that's congruent to a third thing, then I can prove the first and the third thing are congruent. Here's some examples of finding measurements. Again, it's just more practice and work through, and we'll kind of walk through them. It's just what we know. Think of it, a triangle, missing an angle measurement, have to find the missing angle measurement. I know triangles add up to 180 degrees. I look and see I have angles of 64 and 42. That adds up to 106. So my third angle is just 180 minus 106, or 74 degrees. Make sense? Pretty straightforward. Again, third one, second one there, 65 and 70 is 135. That makes this 45 when I subtract 135 from 180. Those are the easy ones. What we're going to see a lot of in this unit, even on the unit test, is the algebra versions of it. Solving for x, finding measurements that way. So here I have solve for x plus 28 plus 133 plus 126 has to equal 180. Combine all my like terms, which is all my numbers. Again, this works out to be 187. I think I have this as a problem for you to do a little bit later on. So here, x equals -7. Pretty simple, straightforward. The angle there then is 21 degrees. I'm not going to do angle A, the second one, because I have that as a problem for you to work on somewhere toward the end. Yeah, there we go, right there. So, your turn. Try to find the measurements. Add the triangles corresponding, find the corresponding angles and sides, figure out what we need to do to set stuff equal to each other, solve for x and y, maybe not in that order. Enter your answers in an ed puzzle, then come back and check and see how you did. Okay. I circled in colors the angles that correspond. A corresponded to D, B corresponded to E, F corresponded to C. So I know what angles equaled each other. So then I'm able to tell the sides between the two correspond. I had to solve for y first, because that was the one that I had. One of my equations was 2x plus y, so I can't go solve for x first, because I need to know what y is. So 65 equaled 2y minus 5, so I ended up with y equaled 35 whatever, degrees I guess in this instance. So that's what my y equaled. So then I had 2x plus 35 now. I can substitute 35 in for y. Had to equal a side. I just had to make sure I picked the right side. I picked the 90.6 side, which is the corresponding side. We found out that x equaled 27.8 units. Does that make sense? These are the types of problems we're going to get this whole chapter in unit. Okay, a couple more. Here they're polygons. All the rules still apply. Corresponding angles, corresponding sides, congruent. The polygons are congruent. It's the same convention from the naming. If the letters are, the order of the letters is how they name the triangle. Those are the corresponding angles. Solve for x, solve for y. Enter answers in the ed puzzle. Come back and check and see how you did. All right, here we go. Again, I circled in colors. A corresponded to P, so the right polygon was flipped, it's upside down. Think of it as a 180-degree rotation. And there we go. So we solve for x. So 2x plus 4 had to equal the 100-degree angle. So I solve x equals 48. Then 3y minus 3 was the 12 side. So 3y minus 3 equaled 12. Y equaled 5. Did that make sense? Everybody got that? Awesome. Again, 2 practice problems. We've already done the first one. That's the example I did. Try the second one. Solve for x. Enter in the ed puzzle and see how you did. Okay, there we go. Again, I wrote in blue what we knew. At a vertical angle, so my inside angle there was 105. 115, sorry. I know 115 plus 2x plus 10 plus 2x plus 7 has to equal 180. Solve for x, found x equal 12. Did that make sense? Does everybody understand that? Again, we're starting triangles. We're working with the basics of triangles right now. They all equal 180 degrees. And we will build on that as we go forward. Okay. I will talk to everybody tomorrow on the half day. Haven't quite figured out what we're going to do. I think we're going to do another example of some triangle stuff, kind of building on what we learned today. And like I say, on Thursday when you come back into school, you'll be able to finish up parts of the test that you hadn't completed. I'll give you probably 20 minutes or half hour to complete the test, or even look over if you've already passed it in. I'll give you a chance to kind of look it back over and make any corrections you think you need to make. All right, I will talk to everybody tomorrow.